There's a few things that we're not quite there yet. First thing we want to do is we want to realize that I've got fractions within fractions. So in order to simplify this, I need to find the least common multiple of all of the denominators up there. I'll highlight those right here. So we got 3 different denominators. So the least common multiple of 8y and 4y squared. Remember, least common multiple has to be at least as big as the biggest factor. So between 1, 4, and 8, the biggest factor here would be 8. So it's got to be at least as big as 8. And isn't it 8? Right? That is the least common multiple, at least numerically speaking. But then I've got a y and a y squared. Do I pick the lower exponent or the higher exponent? Higher. Okay, so my least common multiple is 8y squared. And so I'm going to use that to help me eliminate my fractions. And so here's how that looks. I'm going to put parentheses around both the numerator and the denominator like that. And I'm going to multiply by 8y squared in the top and 8y squared down in the bottom. Make sense? Okay, so notice this as far as like conceptually, I think it's pretty important to note. In the numerator, don't we have a fraction times 2 fractions? But in the denominator, don't we have a fraction times just one other fraction? You see the difference? Up here, there's 2 fractions. Down here, there's just 1 fraction. So the way we approach this to be efficient, maybe it will be just a little bit different based on that. So what I'm going to do in the numerator is I'm going to distribute that 8y squared into both. And so remember, when you're multiplying fractions, you multiply the numerators times each other and the denominators times each other. So the result of this, here's my main fraction bar. When I multiply 8y squared times 1, what do I get? 8y squared. So that is going to be here. And then when I multiply the 1 times the 8, I get 8. Okay, so there's the first part of that distributive property. There's some simplifying we'll do here in a second. The second one, we're going to go 8y squared times 1. That, of course, gives me 8y squared. And then 1 times y gives me just a y. So reflect on what you did, what you're seeing up here. Do you have any questions? Julia, are you with us? Okay, it's okay. Any questions at all? Okay. The denominator we're going to handle just a little bit differently simply because we have a single fraction times a single fraction. In these cases, I think what you can just do is do some cross-canceling right away. So the first thing I see down here is that this y squared would cancel with that y squared. Because one's in the denominator, the other one's in the numerator, you can cross-cancel on multiplication. And then I see the 4 and the 8 would cancel down to be a 1 and a 2, leaving me with 8 minus y, and then that 2 is still there, so times 2. Finish this off. What are the things in the numerator fractions that will cancel out? Like say for the first one, what's going to cancel?
The 8 and the 8.
Yeah, 8 over 8 is 1.
Y.
And over here, this y would cancel with one of those, leaving me with just a y. So my final answer would be y squared minus 8y. And down here, if you want to distribute the 2 like this, that's fine. If you don't, that's fine too. It's either way is not going to change your answer. If you want to leave these as factored, like if you wanted to leave this as y parentheses 8 minus y, and this one 2 parentheses, that would be not that.
We're taking a video of this right now so we can go back and watch it.
I am.
Oh.
Yeah. So it'd be, what do we got here? Y times y minus 8. And 2 times 8 minus y, I guess. Is that right? You're going to leave it like that? I'm fine with it. I think I'd be probably most comfortable if you just left it like this. I'll be fine with that for sure. Okay? Yes, ma'am.
So if you didn't simplify the top, it wouldn't work because you get 0.
If you didn't simplify the top.
Like the fractions on the top of the big fraction.
So the 8's canceling out?
Yeah.
And the y's canceling out?
Yeah, like if you didn't.
I don't think we'd get 0.
Well, 8y over 2 minus 8y over 2.
Where are you getting 8y over 2?
Or 8y squared, that's what I meant, sorry.
But where are you getting the 2 from?
I didn't. it was supposed to be 8y squared.
Oh.
Minus 8y squared. I just said it wrong.
Oh, okay. So I'm looking up here. I'm seeing the 0 right here.
Yeah, I
So,
was confused.
I would say the answer is no, and here's why. In order to be able to subtract or add fractions, the denominators have to be exactly the same.
Yeah.
So I'd say I'd go back to what you said. Like if you didn't cancel the 8s and the y's right here, you would just sort of be stuck right there, right? It would not be simplified. Yeah. So you'd be stuck for a different reason.
Yeah.
Not that 0 is categorically like automatically means you're wrong. In this case, it would. Yeah, you just don't have the common denominator. There's a lot to keep track of, right? I mean, fractions are always a little more complicated. There's no question about that. Okay. Do you feel like maybe you're doing a little bit better right now than you were 5 minutes ago?
Yes.
Yes? Okay, cool. Well, I'll tell you what. Let's mix this up a little bit. I think what I'm going to do is maybe introduce a question or two about what we're going to do today. Maybe we'll come back to this, see if you're still retaining it. Okay? And we'll go back to some equations and newer stuff. Let's kind of mix it up a little bit here today. We'll be up and down a lot with the board perhaps and just kind of hopefully leave here doing pretty good. Look into the future. On Monday of next week when you guys come to class, we are going to should just be able to practice. There's not going to be any brand new material on Monday, assuming that today goes well. Leaving us with Wednesday for a quiz, finish out with Friday for a test. But I'm hoping today will be the end of new material. Okay, it's kind of the plan. Okay, so grab your notes. We're going to do an example or two here. We'll be back up at the board trying this again. We'll go back to the notes a little bit. So should be 7 point, where are we at? 6, I think? Let's find out. 7.6, yes. And you know what? I'm actually going to do something here. I wasn't planning on doing this, but I'm going to transition like this. Let's head back to the board. Let's do this. I'm doing a little bit different than I originally planned, but I like this idea. Go back up to the board. I want you guys to try to do this. Can you guys solve that for x? This is, yeah, it's pretty old. We've done this many times, but it's been a while. Think about the steps you'd need to take to solve for x. In chapter 6 at times, but it's just going to have fractions involved in various forms. So here's how we do this. I want to give you guys some instruction. I think this will go pretty well with what we did with our complex fractions. Step 1, find the least common multiple of all the denominators, just like we did with complex fractions. So here's your denominators, 9, 6, and 3. So what is
18.
18 is the least common multiple of 3, 6, and 9. Agreed. So here's what we do with this. I'll rewrite this real quick. What I'm going to do is I'm going to take that least common multiple of 18, and I'm going to multiply every single term through by that. So I'll note that by just putting the whole thing in parentheses and putting times 18 over 1. So this should feel a lot like what we do with those complex fractions. Do you guys see the big distributive property coming up? So here we go. I'm going to take this 18 over 1, and I'm going to multiply it top and bottom by that term. So what is 4x times 18? 72x. What about 1 times 9? So stop for a second. Listen, really reflect. Does that make sense? Do I see what we've done so far? LCM times one of the terms. We're going to just continue to do that with the other terms. So now I'm going to go 18 over 1 times the second term. So 18 times x is what? 18x. And of course, 1 times 6 is 6. And then lastly, I'm going to multiply that 18 over 1 times the 5 over 3 So what is 18 times 5? Yep, so 90, and of course 1 times 3 is 3. So this might right now look like we've created a little more of a mess than we started with. However, did you notice that a bunch of cancellations will happen? In fact, every single term will get a cancellation. So let's start over on the left. What's 72 divided by 9? 8. So 8x for that left term. How about 18 over 3? Or 18 over 6 is 3. There we go. I jumped the gun on that. 3x on that one. What about 90 over 3?
30.
So I think it's really important for us to note that this equation that we're ending up with right now, this equation is equivalent to the first one we had, but wouldn't you have to agree that it's a whole lot simpler looking? What's different?
There's no fraction.
Fractions are gone, right? So if you multiply by that least common multiple of all the denominators, that should, if you do it correctly, that should cause all the denominators to cancel out, leaving you with something like that. So let's think about what this is. It's a lot like what you just did a second ago. If you were going to simplify this and solve, what would you do first?
Subtract 3x to the other
what did I
side,
just
from
do?
both sides.
You got
And
it.
as well as 30.
There you go. Subtracting 3x, like Colby suggested, gives us 5x equals 30. And then how do you finish this off to get the x by itself? Divide by 5. Yep. So from there on out, it should finish pretty normally. Do we have to find what? Yeah, there's no y. So one encouragement for you, you want to always double check your answers, and I think you can probably do this mentally for sure here. Is this x equals 6? Is that going to cause any issues? Remember how we did at the start of the chapter, we found those values that make the denominator 0? Is the 6, or x equals 6, is that going to make any of the denominators 0? How? Aren't all the denominators constant already? So I don't think it's going to do anything like that. I mean, the denominators are 9, 6, and 3.
What would it be? Like, what would it look like if it did this?
Can I show you on a new example? I'll definitely show you that here in a second. So I would say at this point, I think x equals 6 is going to work for us. I think if we checked it, it would be just fine. Big takeaways, least common multiple of all the denominators. Multiply by that. That should get rid of all your denominators. And then from there, it should be a fairly straightforward equation based on what we've done in the past. Good?
Great.
Awesome.
Glorious.
Say it again. In some form or fashion, yes. Now, you'll see in example 2 that the x's can be in the denominator sometimes, and that'll change things a little bit. But in general, the answer to your question is yeah. It'll be like this every time. Okay, so let's take a look at example number 2. Example number 2. So I want to kind of help you with this one, getting started. Notice, similar form, but this time, denominators have x's. It's not really going to change our strategy, but it might change the way some of the intermediate steps look. The strategy is going to be the same. All your denominators are here, here, and here. What is the least common multiple of all of those? 6x is right. 6x is the least common multiple of all three of those. So what I'll do is I will multiply through by that. I want to give you guys a chance to give some input here. If I do this part, what's the result? 18x over x. Slow down, Andrew. You're going a little too fast for me. Minus 6x over 6 equals... You're doing that well.
Can you cancel out that?
You can, and we will. We will. Are you guys okay with that step?
Yeah.
Okay, so let's do what Rosie suggested here, and let's see if we can get some canceling. Do you guys see how this x would cancel with that x?
Wait, where?
And then in the second term, what would cancel out?
6x.
The 6's, yep. And then
15x.
lows, don't the x's cancel, Sarah?
15.
So I think you just get 15 there. So you'd get 18
18 minus
minus x equals 15. Is this making sense?
You have to subtract. But then it'd be negative x. You don't want a negative x. So you have to factor in a negative 1.
Question.
Which makes both sides positive.
Good question. Hey guys, equation. Hey, before I answer that, DJ, you're doing great. Just be a little quiet. Are you guys all okay with that step? We went through it quickly because I was getting a lot of good feedback from you guys. We're doing okay. So let's address the question: how do we solve this now? What kind of a sign does the 18 have? Is it positive 18 or is it negative 18? It's positive. So if you want to get rid of a positive 18 being added in there, you've got to subtract it. So I'm going to subtract the 18 from both sides. And when I do that, I end up with negative x equals, what's 15 minus 18? Negative 3. I'm not all the way done, just got to divide by negative 1. Yep, so dividing by negative 1, I get x is equal to 3. Now let's do that mental check. Looking back at the original, and I'm talking about back up here. Oops, like right there. What is the only x value that would cause any of those fractions to be undefined or to not exist?
0.
If x was 0, yeah, because if you look at it right here, if x was 0, you'd get 3 over 0. And over here, if x was 0, you'd get 5 over 0. So the only excluded value is 0. So is 3 going to be okay? Yeah. Now, if x happened to be 0, we'd have to be like, whoa, that's not going to work. And we'd exclude it and say, well, that's not the answer. There is no answer, actually.
Wouldn't it be negative 1/6?
Wouldn't what be negative 1/6? You just said, wouldn't it be, and I wasn't sure what it was.
Well, like, I was just thinking, like, if you plugged in the 0 for those x's, the 5 and
Well,
3 would cancel. And then
if you're dividing by a 0, it's a game changer. You just stop. There's nothing else you can do. You just say, it just doesn't exist. The whole equation is invalid at that point.
So, okay.
Yeah, you can't say, well, this part is totally invalid and this part is totally invalid, but there was this one part that wasn't, so we're good. Yeah, the whole thing's bad at that stage.
So you just say undefined then?
Yeah, you'd say no solution. Yep. Hey, let's head to the board. Let's do a little practicing. Basically, we have an equation with fractions. That's all this really is. So here's what we want to do. We want to identify all of our denominators, and we want to multiply by the least common multiple of all those denominators. So I've got 3 denominators. The first one is x minus 4. The second one is a 1, technically, and the last one is an x minus 4. So as you look at these 3 denominators here, what would you guys say is the least common multiple of all 3 of them?
X minus 4. X minus 4.
It is. Yeah, least common multiple is x minus 4. And so I am going to multiply by that. So it would look like this. Was that what directed at me?
No.
Okay, I just wanted to make sure that you're doing okay.
I just got
Wait, how
confused.
does the
My brain
1 go
confused.
into that? It's not a 1, it's over 1.
So,
Yeah, but the 1's the denominator.
so we're looking, so least common multiple is the smallest expression that all of them go into evenly. Doesn't 1 go into everything evenly? In other words, everything is divisible by 1.
Yeah.
So that's why the 1 works here. The 1's really not going to make any change to the least common multiple. It's really driven by the x minus 4s. Okay. So, based on the fact that the least common multiple is x minus 4, just like we did a few minutes ago, I'm going to multiply by that least common multiple. I'm going to multiply every single term through by that least common multiple. So, when I do that, for this first one, let's be really careful about not doing too much here. I think what I'll write is 3x parentheses x minus 4 over x minus 4. I could have distributed the 3x, but I'm not going to because I want things to cancel out. So I'd be really careful about that. I would say don't do that. And then that's going to equal 5 times x minus 4. Of course, 1 times 1 is 1. And then lastly, I'm going to avoid doing too much. I'm just going to write it as 12 parentheses x minus 4 over x minus 4. So give that a look real quick and see what you think about that. See if that makes sense. Any questions? Yeah, Rosie.
Can you cancel out the x minus 4, x minus 4, and x minus 4?
So that's what we're going to do next. Yep. So the reason why we didn't do any of that distributive property stuff is we wanted to cancel. So we're going to cancel this and this. I can cancel vertically only here. And I can cancel this with this.
What the heck? Where's that? Oh, I wrote it wrong.
Okay. We doing all right?
Wait.
Okay. Yeah. I hear your weight, Sarah, but I'm kind of waiting to hear what your weight is all about.
I messed it up. I thought the denominators were 1.
Well, so Sarah, check this out. When I multiplied 1 times x minus 4, wouldn't I just get x minus 4?
Yeah.
And when I multiply 1 times 1, I get a 1 right there. I didn't write it because it doesn't really do anything. And then 1 times x minus 4 would be x minus 4. So what I'm trying to do is teach you math, not tricks, right? So just like think a fraction times a fraction is simply the numerators times each other over the denominators times each other.
Okay.
I was just not,
I messed it up.
Okay. So guys, after you're canceling, you would get 3x equals 5 times x minus 4 plus 12. At this stage, you got to admit it's a lot simpler looking because there's no fractions, but there is some work to be done. Let's review this. Let's review solving something like this. If we were going to simplify this first, as we decide to try to solve, what do you guys see that we should do to simplify it? Got to distribute, yes. So the 5 gets distributed here and here. That would give us,
5x minus 20.
yep, 3x equals 5x minus 20 plus 12. So I've come up here now. And then what would you guys do next? There's a variety of things you could do.
You do the
Definitely not divide. We don't want to do that.
20 plus 12.
Oh, combine, yes. So negative 20 plus 12. Sorry, Sarah, I just misheard you there.
That's okay.
And so that would be minus 8.
And then you subtract by minus 5.
So subtract 5x.
Yeah.
Are you? I hope you guys are paying attention. I'm kind of sensing just some chit chat. It could be really profitable,
And then
but if you're not paying it, oh man, DJ Colby, it's not math, is it? You're about to get really messed up. You should start paying attention right now. Okay. So negative 2x equals negative 8. How do we finish this?
divide by negative 2.
So you might be sitting there thinking, cool, got it, easy and done with. But remember, on numbers 1 and 2, didn't we always check our answers?
Yeah.
We better check our answers here. Is that 4 going to create any issues?
Oh, wait, it
Yes.
does.
It creates a massive issue because if I were to try to check my answer, wouldn't I have to plug a 4 in there
And that's 0.
and there? And what's 4 minus 4? 0. And you can't divide by 0. 4 is actually the only number that doesn't work, right? So, what do we do with this? What we do with this is we simply cross it out. Listen, hey, those of you that are just talking nonstop, stop. I want to be really clear about this because when it's chaos, I feel like nothing happens. I could be wrong. We only got one solution, right? And that one solution, we tried it and it doesn't work, right? It causes a 0 in the denominator. So our conclusion is no solution. No solution. Because the one answer we got didn't work. So it's no solution.
Would it be undefined or no solution?
I'd say no solution. And the reason why I'd say no solution is because this is an equation that we were supposed to solve. Well, like we're supposed to find the solution. So I think an appropriate response is to say, find the solution, there is no solution, right? Versus just saying undefined.
Yeah. If you say undefined, would you get undefined?
I don't know. I think you probably should just say no solution and don't worry about it.
Well, sorry.
It's okay. It's okay. So does that make sense why we should always check our answers? Always go back and make sure that it really does work. A lot of times it will. Occasionally it won't. Okay, let's move on to our final question. And our final question is a lovely, lovely example.
Oh, Lord.
Here we go.
Actually, that's not that bad.
Denominator.
So I'm hoping that your math sense, hoping that your math radar is picking up on something up here. Do you see the factoring?
What?
I heard that it really liked you, though. You should give it a chance. I'm just being silly. Come on.
That was funny. I like that.
I laughed, Mr. Anderson.
I
Thank
laughed
you.
I
too.
got you.
Thank you.
No, but I
Um, So,
No, that doesn't make any logical.
in order to do this most efficiently, we need to factor this trinomial. So will you guys take a minute and try to factor that trinomial? Ready, set, go.
How do you factor it? I forgot.
You suggested to split the b, and that's exactly right. It's a trinomial. There's no GCF, so split the b.
Stop laughing now.
Well, my door is always open. If you want to come back, I'd be happy to work with you some more on that. Here's what it would look like factored. You've got x plus 1 over x plus 5. That's just rewritten. Over here, the trinomial factors as x plus 5 times x minus 2. And you still have equals 1. So that would be where I would start with this. You've got to factor any trinomials or difference of squares or whatever factorings there might be. You've got to factor before you do anything else with this. Okay? So, once you've found the factors, we need to find the least common multiple of the denominators.
X plus 5. Oh, X plus 10.
It's both of them, isn't it? It's the product of the two unique factors. So your least common multiple is going to be x minus 2 times x plus 5. If you look at your denominators, you really only have two different factors down there. You've got an x plus 5, you've got an x minus 2. It's true that the middle term has both of them, but those are the only two unique factors, and so the LCM will be the product of those two. So from here, this should follow the exact same pattern of what we did.
Oh.
Hey, and by the way, listen, I realize this is a lot to bite off and chew, right? So as I mentioned before, on Monday, this is our last example. So when you come back on Monday is going to be all working together to refine this and get better and better. And if you're putting in some time on your WebAssign, that'll supplement that. You'll be that much better. Okay, so if you're feeling a little panicky, you're going to be okay. All right, so here it is. We're going to multiply by the least common multiple.
Oh, yeah, you're right.
Wait.
Hey, guys, quiet down. So we're going to multiply by this. And when I do,
That's wacky.
here's what results. It's going to be x plus 1 times x plus 5 times x minus 2 in the top. I'm just doing that first one. And I'm not going to FOIL any of this stuff out. That's just going to create more work. It's just going to make it more difficult. So just list them out being multiplied together. And then 1 times x plus 5 is x plus 5. Can you guys Sarah, stop interrupting. Can you guys foresee the cancellation that's about to happen?
Yeah.
Okay. Here, when I multiply in the middle, 1 times the x plus 5 times x minus 2 is just that. X plus 5 times x minus 2. And then don't I get the exact same thing in the denominator? 1 times x plus 5 times x minus 2. So again, can you guys foresee the cancellations there? It's going to be pretty convenient. And then lastly, when I multiply here, I get x plus 5 times x minus 2. And then 1 times 1 is just 1, so that's not going to really do anything, right? So I'll just leave it as is. The cancellations. The x plus 5s cancel out. Here, everything cancels out, right? When everything cancels out, what are you left with? A 1. Okay, so as I seek to finish this up, do you see how this was left over here and this was left over here? Can we go ahead and FOIL those out? So if I FOIL them, I end up with x squared. Question?
Yeah, do you have to FOIL them?
You really do, because we're solving. We need to get the x's all by itself, so got to simplify it, kind of like we did in the original example. Got to do some simplifying. So it'd be x squared, let's see here, it'd be x squared minus x minus 2 when you add your middle terms. That whole middle term there just cancels out to be a 1, like you guys mentioned earlier. And then wouldn't this over here just FOIL back out to be what we already knew it to be at the start?
Yeah.
So it'd be x squared plus 3x minus 10. Looks a little intimidating. No, Sarah, question.
I just got so lost.
So we FOILed. So what I did is I multiplied x plus 1 times x minus 2
Okay.
and FOILed. And this is the result of that foiling.
And then why does it equal x plus 5, x minus 2?
So over here, the original equation had an equals 1. So when I multiplied by my least common multiple, I multiplied x plus 5 times x minus 2 times 1. Doesn't that just give me x plus 5 times x minus 2?
Yes.
Okay. So again, I would encourage you guys, I'm trying really hard to just teach you math, not tricks. And so anytime you multiply fractions, you go numerators times each other, denominators times each other. We're just doing that kind of repeatedly. Hopefully the repetition helps a little bit. Sarah, you good?
Yeah.
Okay, so here's how we'd finish this off. Did you guys notice how there's an x squared on both sides? I could clear that out right here just by going minus x squared from both sides. So those are gone. That's kind of nice. And then isn't negative 2 plus 1 just negative 1? So then how would you guys finish this off? Negative x minus 1 equals 3x minus 10. Any suggestions?
Plus 3.
Plus 3x? I don't think so because it's already a positive 3x.
Plus x. Or minus.
I'd go plus x, yeah. So if I go plus x to both sides, that would give me negative 1 equals 4x minus 10. How'd you guys finish this one off? I don't think I want to add the 1 to both sides because that would be putting the 1 with the x side.
Minus
Why not add 10? Yeah, if I add 10 to both sides,
9.
that'll give me 9. I'll come up over here to finish. 9 is equal to 4x. And finally, divide not by 9, divide by 4. So x is equal to 9/4. So if you wanted to leave it as that, you're fine.
That was a lot of work.
It is a lot of work. I agree. I wouldn't look at that and just be like, come on, that's easy. Right? It's a lot of work. It is. Any questions? Let me give you the opportunity to ask questions.
I got lost somewhere. So after,
So I think where you got lost is, I don't think I would do this first. I would subtract my x squareds out first. That was my first step, Morgan, right here.
there, so you can both cross them out.
To me, that clears things out a little bit.
Then that's wrong.
Right, so then,
Then you would add the x.
sure, you could add the x to both sides. There you go.
So then it's negative